Okay, are we ready to get started?
Yes.
Yeah. Are you able to see my screen? I can't see it on my own Teams link.
Yes, we can see.
Yeah, we can see.
Okay, perfect. Okay, so hi everyone, I'm Tom McQuillan, and in this presentation I want to talk through databases and LabVIEW, but I'm specifically going to be looking at SQL and what SQLite actually is. We saw a bit of an introduction through what Steve was talking about and how he uses it for configuration and data storage and logging. And so we're going to be looking at that as well. But before we get started, I want to be clear that I'm not an expert in SQL or SQLite databases, but the more I use them, the more I want to become that expert because they're super powerful and they've really solved a lot of configuration issues with my applications. So I'm going to start off by looking at why we should be using a database. First and main reason why I got into databases is because of application configuration. Databases are super flexible, and so in my applications I have multiple user accounts, and for every user account I need different configuration settings. I have a dynamic number of hardware or pieces of hardware that all have different configurations. I have different color schemes for my applications, and every user might have a different color scheme. And I want all of that information in one centralized location that I can explore and get data out of. The next is data management. So how can I access that data? See, before I used databases, I was using things like JSON files or XML or INI files, where a lot of the time for configuration, I had to bring the whole file into memory, then search it using array manipulation, then get the data out, which is a super expensive task in terms of resources for really not much gain. Whereas with databases, we can just get the information we need out. And the next is data storage. Obviously, with a database, we can just throw lots and lots of data at the database and it will just hold it there. So I'm going to start off with a bit of an example of a database, just so we're all on the same page. And the type of database I'm bringing onto the screen now is one called Chinook. And this is an SQLite database, which you can download for free from SQLitetutorials.org. But we can see that this is a single database called Chinook, and it has 11 tables in it. And each of these tables contain a concise piece of information. So we're currently in a table called tracks. And the only thing that this table holds is an ID, the name of the track, maybe a composer. Even it gives references to other tables like album, media type, or genre. If we go to like the album ID on the left-hand side, or albums, you can see that this again is a very cohesive table. It only contains one piece of information, which is album ID linked with a title. Even this table is then linked with an artist ID. The artist ID just contains a name and an ID. As you can see that this single database can hold lots and lots of information in a highly cohesive manner. And when we're developing code or code modules, we're always told to have high cohesion and low coupling. Well, the same is true for our data. All of these tables have a very high cohesion. But also, each of these tables, they don't have to be related. For example, I have an invoices table here, which contains 412 rows of information about invoices that have been made. And that's completely different to a big list of tracks, of which there are 3,500 tracks just in this small database. if we look at how this database is structured, we would come up with tables that look a bit like this, where you have individual tables such as media types, genre, track, playlist, customer, employees, and they can all be related in a particular way, which is demonstrated by these wires. And each of these wires have different symbols on to demonstrate whether it's a one-to-one relationship or a one-to-many relationship of the different relationship types between these tables. So tracks is related to albums because track and album both have an album ID. Albums and artists are related because they both have an artist ID. And so we could work through this big database and get specific pieces of information from individual tables. But it's really important to note that although this database has, I think, 11 tables, it's only one file on disk called Chinook. And actually the file extension .db, that doesn't matter. You could come up with your own file extensions like I have. So in my applications, I have a custom extension, and I've made it so when Windows notices that file is opened, it opens up my application. And you can do that with some token keys in your LabVIEW ini file. But it just makes for a much more professional application in my mind. But given how separated this database is across 11 tables, you might start thinking it's quite difficult to get just a simple table where I have my tracks, I have who it's by with an artist, and what album it's on, because they're all in separate cohesive tables. But with a thing called structured query language, we can navigate this database really quickly. And you might hear people call it SQL or SQL. They're all synonyms of one another. So just a quick introduction to what SQL or SQL is. It's a type of language, but instead of a programming language, it's more of a query language. And this query language we can use to communicate with relational databases. So databases which are built up of multiple different tables, and those tables are related to each other in some way. Much like we saw, tracks and albums are related. So with SQL, we can pull, edit, add data. We can even change the infrastructure of that database. We could create tables, and in each of those tables, we could add columns. But we can also use SQL to analyze that data. And so one thing that I've started to do an awful lot is I'll capture the data that I want in the database. Even in the database using SQL, I will manipulate that data. For example, if I want a running average of the last 100 or 1,000 results, I can get the database to do that for me, instead of bringing all of the data into LabVIEW memory, and then performing the analysis in LabVIEW. I can just do it all in the database using SQL. So I'll bring up just a little test bench I created, where I can write some SQL queries and it will return some results. So the test bench that's on the screen now is connected to this database that we saw with tracks, artists, customers, etc. And so I can write some queries to get data from that database. But before I do that, you should know that because SQL is a query language, I could do something as simple as select what's 5 plus 9, then send that, and it's returned a result of 14. I could do a bit more complicated and multiply the numbers together. It's come back with 45. And so you don't need to just use SQL for looking into databases. You could do simple arithmetic like this, but the power comes from getting data, performing arithmetic on that data and returning a result. So let's look at that now. Let's say I want to select all of the data from the employees. So I can write an SQL query of select asterisk then employees or from employees. And that's returned employee ID, last name, first name, title, reports to, and date of birth. But let's say I want to find out, okay, who's the oldest employee, and I want to sort the data based on age. Well, instead of bringing all of this data into LabVIEW and sorting it, I can just put an order by statement and say birth date. And I'm just pressing F9 to send that query. And you can see that now the oldest person is at top. But notice how when I typed in birthday, I made a mistake. I accidentally put a capital A instead of a lowercase a. SQL as a query language is really forgiving. And so it doesn't matter about capitalization. In fact, it doesn't really matter about white space either. And so I've been putting a new line just to make my query look a bit more readable. But I could put in loads of white space, run the command again, and it will still work. Or I could change the order like that, so it's descending instead of ascending. A lot of the time, we don't just want to get all of this data out. I want to know the current age of my employees. So I'm going to say select first name. And now I want to select birth date. So I can run that query and it's replied with first name and birth date, but actually I want to know how old they actually are. Actually, I don't want to know their date of birth. So I'm going to use current time, current underscore timestamp, fact, and now I have the current age of all of those employees. And so with SQL, I've been able to actually manipulate that data and get what I actually want. But just saying, but having this as a column header, well, that's not particularly user-friendly. So we can write something else. Reply to this as an age. And so not only can I manipulate the data, I can change how that data appears. And so see, this is just a 2D table that I have in LabVIEW, and it's formatted the headings just as I wanted. Okay, let's just go back to selecting all of the data in this table. Have you noticed that in a lot of databases, or a lot of times where you have to enter your name, you enter first name, and then you enter your last name in 2 separate fields. So that really helps with user interfaces. So if you're told to enter your name, as a user, I know, oh, I should enter Thomas, and then separately enter McQuillan instead of saying Thomas McQuillan in one field. Or you might have someone else who puts McQuillan, comma, Tom. So by separating your data into separate fields, like this, it means that everyone is on exactly the same page. However, having separate fields like that isn't very user-friendly. If you want to just output someone's name, you would want Jane Peacock, not 2 separate fields in an array. And so you could do that by just saying first name. And I want to concatenate first name with last name. And so what I've done here is just add an extra column to the start of this reply field to say what's their full name. And again, instead of saying first name concatenate last name, full name, just like that. Okay, so hopefully that's shown you like some of the things we can do with SQL. But let's go back to another table. So the tracks table in here has quite a few columns in it. Is everyone's still able to see my screen? There's a comment just saying video hung.
No, it's still working for me. So
You can see it moving?
yeah.
Okay. In that case, I'll continue. So let's go back to this tracks database because that has a few thousand results. So I'm going to select everything from tracks and click.
All right, Tom, it looks like a lot of people are having trouble with the thing. So
Okay.
do you want to disable your video? Just
I'll turn off my camera. Okay, if I move the screen, can everyone see that moving smoothly?
It seems good for me.
Yep, so I'm getting a couple of yeses through. Okay, perfect.
Yeah.
I'll
I think
continue.
we're okay. Yeah.
So I was just getting all of that information from tracks. And so I'll just clear the screen and show you that again. So you select everything from tracks. And when I click F9, notice how all of this data seemed to populate itself in a single instance. So that, if you look at the bottom here, 3,503 rows, all complete with strings and numerics, all loaded much quicker than I, as a human, would notice. Okay, but let's say I want to be able to tell, okay, what the name is and which album it's on. So I've got the name here, and so I can just say select a name from tracks, and that would reply with all of these names. But the album ID, well, this is referring to another table in the database. The album ID is part of this table here. And from the album ID, I could work out what the title is. So I'm going to say select name from tracks. But I could also say select albums from tracks. Then now I need to join those tables together. And I'll just separate it so it's a bit clearer. So now I'm going to join the albums table and the tracks table together. So I'm going to inner join albums. Then I give it a condition. I'm going to join albums to tracks on the basis that albums.id is equal to tracks.albumID. And that's equals to tracks.id. Okay, so now I've been able to bring in two lots of data from two different tables. But actually, this is still 3,500 results, which you probably don't want to show 3,500 results to the user all at the same time. So instead, let's just limit it. So the first 100 results. let's say. And so now we only have 100 rows. Even, let's say you want to scroll this information. So we've now looked at the first 100. I'm going to now offset it to the next 50. Even in my code, I could offset it to 100, even 150, etc. And this is what I also use when I have a custom scroll bar in my applications. So if the user keeps scrolling to the right, I can just add more data, and I'm reading that data from the database. And I'm reading that data fast enough that the user doesn't notice I'm just loading it from file on the fly. Okay. So I'll just close that, and I'll quickly show you the code just to show you how straightforward the block diagram is. I'm just opening a reference to that database, and whenever I click F9 or click send query, I'm using this function to send the SQL string, and it returns the column headers and the results. I'm then using the matrix size function to get rows and columns. One last thing I'll show you actually is, instead of doing this arithmetic here, I could just do a simple count. So I can count how many track names and album titles there are. Oh, we didn't like that. Maybe just simple. So I could just do a simple count like this, count how many of everything there are in tracks, and you get 3,503. I'll make this code available to anyone who wants it. There'll be a link at the end, I'm sure. Okay, so there we saw a bit about SQL, and that was looking at an SQLite database. And whenever you Google like what is an SQLite database, you always get these things, but it's all self-contained. You don't need any support from, well, you need minimal support from an operating system. It doesn't have, I think there's one DLL that you need to have installed, but it's widely used in embedded devices because it is all self-contained. You saw that I'm interacting directly with a single file. And that single file doesn't need a server, so you don't need that client-server architecture. I'm essentially just reading data from, it's as simple as reading data from a file. And it operates in memory on your local machine. And so you can do things like just having the entire database in memory in a separate instance. And so it means that getting data from that database and reading it in is super quick. And we could use it directly with multiple different applications. Zero configuration, just plug and play. And lastly, it's transactional and ACID compliant, which basically means if you send an SQL query or make a transaction, that transaction is going to happen 100% or not at all. So you don't run the risk of having partially complete data. You either get all the data or you don't, and you can set up an error mechanism. So if the transaction fails for some reason. There is some more to this slide, which is that SQLite is open source. It's free, so you can download it. However, even though it's open source, it is so widely used. It's used multiple times on apps on your phone. LabVIEW actually uses SQLite in the background. And so a lot of massive companies are using SQLite. We can use the SQL So we can use SQLite for multiple platforms. So on Windows, on Macs, Linux, Android, etc. And so if you have an application which you're using on your Linux RT Rio system, for example, you could use the same SQLite database on your RT system as on your Windows machine. It's super efficient, will only allocate memory that it needs. But as I said earlier, you can make it so Windows brings the entire database into memory to make it much faster. And if you're making a desktop application, like I mostly do, that's fine. We have big, powerful PCs now. And there's a broad range of programming languages, or a broad range of APIs for programming languages. And so I have an application which I'm primarily using LabVIEW, but I also need a Python and a C++ interface to communicate with my software. And so all three platforms can use the database. And it is super flexible. Okay, that's enough slides. Let's go back to some code. And so performing actions like opening a database, we can make sure that the path is valid. You then create a reference like you see here. Just on a side note, this broken wire is just because it's a snippet of a private function. And so the snippet automatically breaks the wire. But we can open up this reference. And what this is all doing is saying, OK, is this database valid? Yes or no? Or have I created a brand new database? If I'm creating a brand new database, well, it means I need to structure that database. I don't just want an empty file. So I have this little VI here called SQL database structure. And inside this VI, all it is a huge long SQL query. And so if I need to create my database from scratch, that's fine. I can run an SQL query to create all the tables with all of the columns. I can set different parameters and default values. And I can also insert default data as rows. So I don't want my software to be dependent on whether or not this database exists. If it doesn't exist, I want it to be created, much like deleting the LabVIEW ini file. If you run LabVIEW again, it will create the ini file for you. But storing that database as SQL, even though it was a huge long list, with any SQL reader, you can typically export that database as an SQL string. So here I'm exporting it as a string just to my clipboard. And you can see that this is a massive long string made up of lots and lots of SQL queries. And an individual query will be any section of code that's terminated by a semicolon. So here I'm creating a table called albums. These are the columns in my table. And then there's a semicolon here. So this is one transaction. Also, that's one SQL query. And then I'm inserting into that database, into that table. So I'll just run that again. In SQLite Studio, I'm going to select it to export the entire database as SQL. And I'm going to send it to my clipboard, and then finish, and then I can paste it into LabVIEW. And so although it's a huge long string, you don't need to write that yourself. You can define your database in a database viewer, which makes it very easy, and then just export it as SQL into LabVIEW. So that database which I exported has 11 tables and about 93,000 data points. And just because I was curious, I want to see how long it would take to generate this database with 93,000 databases, tables, and data points. So if I run this now, you'll see it only takes about, I think, 8.5 seconds there. And I'm benchmarking that very, very crudely, but you get an idea of how fast this is. So actually streaming data to a database wouldn't take that long at all. Sending 93,000 data points to a database would take a fraction of a second, but we're also configuring all of those tables and all of the columns in the table and all of the attributes to those columns, as well as the data points. But this database doesn't have to exist. Yeah?
Sorry, mate. There are some caveats to do with inserting data into SQLite databases that if it's not in RAM, if you're going straight down to hard drive, it takes one rotation of the hard drive. That's how it does the acid test.
Okay.
So you can do it in great big blocks, and that makes it much faster. But it's extremely fast to read, but there are caveats on the insert speed that may catch you out.
Yeah. Yeah, absolutely. So thanks for that, Steve. But as you can see in this query, I'm not, as I say, an expert in this, but you can see at the very top, I'm beginning a transaction. Even if you go right to the bottom of this long string, you end the transaction. So hopefully that's all seen as one single item for acid to say whether it's done or not done, as opposed to all of these individual queries.
But if you're streaming data and you say got like I don't know, an array of numbers and you want to put it in every however many seconds, there are then limits to that type of reaction and a RAM-based one. There are lots of ways around it.
Yeah, I will see one of those in a bit. But that database doesn't have to exist on disk. We could have an in-memory database like we see here, where I'm using James Powell's API for SQLite, where I'm opening up a database just with an empty string. And so if I don't define a file path and I just have an empty string, that's going to be an in-memory database. Then I'm going to execute some SQL, where I'm creating a table called test. I have a column called configuration data, and the data type for that is text, but I don't actually need to define a data type. Then the next query, I'm inserting into test configuration data with a value of %s, which is an object, a number, and a string. I can then read that out on the other side, and those two values are going to be equal. And so with SQL databases, so with SQLite databases, you don't need to be fixed with this essentially a 2D array of columns and rows. A single string input could be a JSON file, or what I'm showing here, an XML file. And in fact, there are SQL queries you can send to query information inside a JSON file. And so if you have user configuration data, which is by its nature a bit dynamic, where you want to add and remove items, you could just insert a JSON file into a cell, and then make an SQL query to query the data inside that JSON file, or JSON string, I should say. So for this next example, I want to show you streaming data to a database. So this is something which I do. I'm going to show you James Powell's example, which you will find in the example finder, where you download his toolkit. Essentially here, I'm going to save, let's say, 1 million data points into a database. I can click run, and it will take a bit of time because it's 1 million data points. But you can see here that in this window, I'm just taking the first 1,000 data points out. And at the bottom, it gives a rough estimate of how long it took to insert all of that data. How many data points per second it took to insert that data, which was about 500,000 data points per second. Now, as Steve pointed out earlier, the way that we get that sort of speed of 500,000 data points per second is by grouping as much as we can into a single transaction. And if we look on the block diagram, you can see that this block diagram is a bit more complicated than the simple execute SQL function that we had earlier. But essentially, once we've created our database, which we're doing here, we can prepare the database for a particular transaction and just write data. So we're writing data over and over again as fast as we can for, we set this for loop for 1 million. We can then commit that transaction at the end. As Steve pointed out, if you were just to do this in lots of separate SQL inserts, it would take a lot longer than a few seconds. Okay, so the next example I want to show you is how I'm using SQL as a configuration database. So it's all still one database, but I have lots of tables in the database. So in my last presentation I did at UKTAG, I showed an application where I want to change the colors and the background of panes and splitter bars and controls, etc. And for every user profile, I might have a separate section of user-defined colors. And all of that is being stored in the database. And with this code, I'm just reading from the database and storing it into a map. I can then send that map around my different modules. But if we look at this SQL query, I start off by just finding out, okay, which profile is currently logged in. So, and that's going to give a number between 1 and, 1 upwards. And that's going to return the profile ID. Then from the profile ID, I can work out, okay, which color scheme did that profile ID want? Then if we work up again, I can select all of these colors from the color scheme based on the ID. So you can build up lots of nested SQL queries as well. So here I have an example of a doubly nested SQL query to get the exact data I want, nothing more, nothing less. But let's say that the database became corrupt and it no longer worked. Well, I can just define some default data values as well. So it might be a bit of an annoyance, but I'm not just going to set the application to a black background, black splitters, black text, etc. Now, one of the last things I thought I'd talk about is the database connectivity toolkit, which I think comes with LabVIEW Pro. I think you can buy it separately. This is something which I used to use. I don't anymore because I just use James Powell's SQLite toolkit. But although this database connectivity toolkit uses a lot of the libraries from lots of different providers, like there's quite a few Microsoft providers and Oracle providers, if we dig down into some of these functions, like create table, we can open up the block diagram of that. And although it's a bit messy, if we just follow the pink wires, follow the strings, we'll see that we're just creating an SQL query of create table, then it's formatting some parameters here. Then with this function, we're executing that query. And so we end up with something like this: create table, table name, columns, attributes, and then send that off to the database. And so I wanted to show you this because if you want to learn how to interact with databases or want to use them, it's really powerful to just learn SQL. Like, invest the time to do online training courses in SQL, start off with smaller applications, etc., because it's not just something you can use for SQLite databases. The database connectivity toolkit uses SQL to interact with databases. You could be working in Java or C or C++ or Python using SQL to communicate with lots of different database types. So it's well worth learning. So in terms of getting started, what I did, I downloaded the SQLite files from SQLite.org. And then the guy who's leading this in the LabVIEW community is James Powell. I've been using his toolkit an awful lot, so has Steve, so have so many people in the LabVIEW community, so massive kudos to him. But watch his presentation from GDevCon, I think it was GDevCon 2, his application design around SQLite video, which is a super good watch. Next, obviously, download his library from the LV Tools Network. Even to learn SQL, I just went onto an online course provider called Udemy and did 2 courses on comprehensive SQL and SQLite. In then I just watched a few videos about database design, so the best way of structuring all of this data. You don't just want you don't just want a single table with all of your attributes. You want your tables to be highly cohesive, so a single purpose. I see there's a few comments in the chat here. So Shree's just asked about the desktop applications. So I use SQLite Studio, and in SQLite Studio I can create tables and then add different attributes to this table. And instead of using SQL to manually type out all of these attributes, it's all configuration based. If I look at a particular item, I can see all of this data as well. I can also open up the editor, and everything I showed you in LabVIEW I can do from here. So select everything from tracks, and you can see that returns the same data as I saw in LabVIEW. Shree's second question was, what about security? With SQLite, you can't password protect your files like you can do with other database providers. However, you can download an encryption software for your databases. That's not open source, that's a paid for service. It's not something that I've used, but I know it is available. And so, yeah, that's everything that I had planned out to talk about. If anyone has any more questions, feel free to unmute your mics. Yep, so Michael's question there, so I will encrypt the database file. To be honest, I'm not entirely sure how the encryption add-on works. I just know that encryption is available to purchase. But yeah, if you look at SQLitetutorial.org, there's an entire section about encryption. It's really well documented, so you can go through it there.
So the desktop tool I use is a paid for one, which is Navicat Lite, which is about 80 quid. And the reason I like it is because everything it does creates a query. And you find that intensely useful because you just cut and paste the query it creates. So when you're navigating, if you delete a row, it will give you the query for deleting a row. And it's got a query builder as well. So you don't have to type in, select whatever, you've got a query builder. So you can build big joined queries without actually typing it. I've used it for donkey's years, and it's made its money back many times. I can demo it if you want. I've got a couple of other useful snippets I've learned over my years of using SQLite. The vacuum command is fantastic. So an SQLite file will always increase in size, but it will never never decrease. And the vacuum command decreases it. So you'll find that to keep it data safe, they never, even if you delete stuff, they don't actually remove it from the database. So that's a good one. I like that one. And databases that are self-describing are very good. So MySQL, it's got a very similar version of SQL as SQLite, has a describe function, which SQLite doesn't have, but it does have a pragma self-describing function. Let me just find it. It's pragma table info, and you give it the table name, and it tells you what a table's built from. And what that allows you to do is to make a generic query user interface, and that's very useful. I've got an example of that on my blog. If you go finding it, self-managing designs. I think it's even a downloadable. But that's quite handy if you just don't want to be writing specific things. So that's all my database things I can think of. SQLite.
So Matthew is asking if you know of any portable applications where you could sort of take it to a customer site to debug anything. Are you guys aware of anything like that?
Well, I suppose if your customer is using SQLite, then it means the customer already has the libraries installed. And so long as you can, if you know the SQLite file path, you can use something like I had earlier, which took like it's just a few minutes to send commands. No, Steve, you know anything?
Isn't SQL Studio just an executable? I know there is just an executable.
Yeah. So this is just an executable in program files.
It's pretty small. What makes that one quite good? I mean, Navicat's a bit bigger, but that I think is just an executable. It's a freebie download. Yeah. That's one of the benefits of that. You can have that as part of your dependencies even.
So Steve, when you were using your user configuration, you said, I mean, depending on who logs in, I mean, they are able to see different things. I mean, so which means that essentially, I mean, somebody else could open the database in SQL Studio, for example, and then modify the database because of the security?
Yep.
Okay.
Yep, I use a security method of being big and scary. People don't do that. Generally, the simplest thing is you just, like Tom does, is give it an innocuous name and hide it somewhere. And that's probably good enough. People get very bent out of shape about security, but I mean, you can secure the contents as well. That's the other thing. But generally, if you charge people a lot of money, if they piss around with your stuff, then they go off that idea.
Okay. Any other questions, comments? Please unmute and talk as well. I mean, if need be. Yeah.
I do have one other top tip, actually stolen from James Powell, for dealing with tables. You might have seen it when I showed the tow tank that I was making. You know, it had thousands and thousands of rows, and I was making the rows pink and stuff. That actually, that's all a lie. You know, it's all a fabrication. So it's using funky sort of slide bars and things like that, and using the limit command when you do a query on the database. So you limit it to 100 to put 100 rows in, and that speeds up things markedly. So there's some tricks you can play to make accessing large amounts of data into tables much better.
Okay.
Regarding online courses, also, I'm not sure if that's been mentioned yet. There is like the Codecademy online course, which is really good. You don't need to you don't actually need to install anything on your PC or so. It's all through the browser. It's free, as I said. So that's basically how I learned everything about SQL. So we are using MySQL servers basically at our place as well. So yeah, it's that course I can definitely recommend.